Hello, everyone. Thank you for the kind introduction. So my presentation today is named Burping Through Your Cryptography Shield. Let's see what that is. But at first, a little stuff about me. Who am I? I'm neither root nor GID UID 0. I work as a pen tester at Atos. Who here knows who Atos is, besides a silver sponsor at DefCamp? The next time you watch the Olympics, watch the sidelines or the commercials. You'll see Atos there. We're a provider for them. I have a Bachelor of Engineering at Polytechnic University, a Master's of Engineering, and a Master of Sciences ongoing. I'm a member of the Romanian security team community. I'm a previous speaker at DefCamp last year. At OWASP this year, I'm a certified ethical hacker. And my main interests are web app security, infrastructure security, and also IoT devices and their security. You can contact me on Twitter. That's my handle. And let's have a quick round of questions. Who here is a developer? Great. Who here is a penetration tester? Okay, so you're going to learn a few stuff today. What's burping? So as per Wikipedia, burping is the release of gas from the digestive tract through the mouth, of course. But we're not here to speak about this. I kid. Okay. Burp Suite is the leading software for web security testing. This actually is a print screen on their website. Is that so? I don't know. We shall see. We're going to talk also about thick clients a little bit today. On the short line, thick clients are a client-server database type of setup of application architecture, where a lot of the application logic is done on the client, but it also communicates with the server a little bit. Okay. So what was the problem that I encountered that led me to make this presentation? I was on a pentest assignment. I had a thick client in front of me. I managed to set up Burp. Burp is a system proxy. Is a proxy, a web proxy actually, and I set it up as a system proxy in order to intercept requests made by the thick client to the server to see if anything funny goes on that application. I finally managed to intercept the requests, and what I saw, some SOAP requests, cool. The only problem was that the data there was complete gibberish, encrypted or encoded stuff. I did not know at the time. And as a motto for this presentation, thick client penetration tests are always fun. So that's me. I look like a cuddly bear, don't I? And I was stuck. The first step I took was decompiling the .NET application. I'm warning you, those are not real screenshots of the application. You wouldn't understand anything anyway, the resolution is horrible. Okay, so I decompiled the application using .NET Peak. Don't know if you know the software. It's a free .NET decompiler and assembly browser made by the guys that do all the cool tools out there for software programmers, like IntelliJ, I think. Yeah, so I used that to decompile the application. And yay and behold, I found the encryption class method that was used. And I found an issue here, an issue that I would like to tell you about, why it's never a good idea to implement your own crypto, or if you do, do it the proper way. The developer of the application managed to hard code the IV in the client, the injection vector, for the first thing. I discovered it was using AES-256 encryption, and the developer managed to have the IV, not a real screenshot, to have the IV hard-coded, and the key generation method was also there on the client. The thing I did, I generated my key also. It was the same key as the application. I had the IV, and I used this cool little tool called CyberChef to test it out. The right-hand the input was the encrypted text, and the output, which you cannot see, was the decoded output. Because I had the key and the IV, it was using IS-256 with CBC mode on, and I had the decryption. What was the problem? Because we are starting to get there, no? We have the requests, we can see them, we can decrypt them, which is cool. But the problem is decrypting, decoding, modifying the parameters, re-encoding, re-encrypting for each request and for each modified parameter would have took a lot more time than the assigned time for the pen test. So I have Burp here giving a hand. I don't remember the name of the little child in the cartoon, but that's Burp now. Or at least I thought so. My Google foo wasn't providing. I first wanted to use a macro, a Burp macro, to decrypt the content, but it didn't work. I've wasted half a day doing that. I was literally stuck again. But then the offensive security motto, try harder, came into my mind. And I thought about why not write a Burp extension that does what I needed to do. It's the easy way to extend Burp features, isn't it? That's what they say. That's the landing page when you click the first result on Google about extending Burp with an extension. And that's what you get. This example does nothing at all. It's written down there. Yay. I never wrote a Burp extension before. I just used them, the ones provided by the almighty Albino Wax or whoever develops them. And I was stuck again. I went on Google, I researched a lot more. I saw they have some sample extensions. I looked at them, I studied them, and then I was stuck with a decision again, what language to use, because Burp, as a solution, supports extending it with 3 languages, or 1 language but 2 other wrappers. The main language, the tool is written in Java, and it can use Python or Ruby to be extended, or actually Jython and JRuby. Those are wrappers of Python and Ruby over Java. Okay, Java I don't like. Ruby I don't know, so the solution was simple. Jython it is. So we went on with Jython. And I found something on the blog on Portsfigure, the developers of Burpsuit. They had an extension written that did nothing, but added a custom editor tab to the intercept, which is what I wanted to do, basically. I got that extension. I started to look through it. They provide it in Java and Jython also, which is great because I don't like Java. And I started writing it. What was the first thing I had to do? I didn't tell you earlier, but the data, the encrypted values, were sent in sub requests to the server under 2 XML tags, write object and read object. Where the first step that I took was to look for those patterns using a regex for the end and close tags. I was thinking when Burp catches this request, it should launch the new tab in intercept. So I started to decrypt the payload, but I stumbled onto a problem. Everyone knows the famous PyCrypto implementation library in Python, It was IS. Come on, it shouldn't have a problem. It wasn't working. Why? Because I'm not using Python, I'm using Jython. So don't be that fast. PyCrypto doesn't work in Jython. Fortunately, after my heart was broken, I found my superhero. This guy wrote the wrapper for PyCrypto API, but for Jython. He was my superhero that day. After losing about 3 hours debugging the problem, you'll see in the end slides why debugging is an issue in Burp while extending it. This guy was my hero. After using the JCrypto reimplementation of PyCrypto, the decryption worked by magic. Okay, so I wrote the encrypt and decrypt. Why the encrypt also? Because I wanted to modify the parameters and re-encrypt the values and send them to the server, because the communication wouldn't work otherwise. But I was stuck after the decryption with .NET serialized objects, which are cool objects, not. And the struggle with Google fooing begins again. This guy is my second superhero. He's the only guy that thought about writing a .NET binary formatter passer in Python. It's the only repo on GitHub, and I wouldn't want to do that by hand, never. There are other, this does them to JSON. It translates them to JSON. There were others that did XML, but I had issues with them. Ajax, wherever you are, bro, you saved my life. And after that, I went on with writing the extension. This is the method to set the message. When it finds the right object or the read object pattern, it checks if it is a request. If it is, it decrypts it, it decodes it, and it prints it out. And if I modify it, it redoes the same thing, but in reverse. It encodes it to .NET binary format, serialized object. It then encrypts it with the key in the IV, and then packs the message and sends it to the server. I told you earlier that I had big problems debugging Burp, because the Java stack trace in Burp doesn't provide any clues when using Jython. It provides the same error every time. It doesn't matter what you do. The solution was adding this library, security MB, from security MB, Burp exceptions, and putting it in your project folder, importing it in your code, and just calling it at the end. Yay, and behold, now any Python exception is thrown in the extended output tab, and you can debug your code, which is cool. And everyone, please, drum roll sounds. Yay, the isDecrypt tab appears. After, I think, 2 days of work, this works. And I can pen test the solution now. That was my presentation. I know I went a bit fast through it, but we didn't have a lot of time. And I hope you guys have some questions. If you do, there are some bowls here for you, and some hats, I guess. And I hope I can provide some answers.
Thank you so much, Cosmin. So yes, we are waiting for questions. First 3 questions will win hats. So, yes.
Hello.
Hey.
The key was actually hard-coded, where it was generated based on some hardware stamp or something like this?
The key was generated using a built-in method in .NET. I don't know exactly, but it was very easy to redo the steps to just call the method, and I got the same key. But the IV was hard-coded.
Okay. So how Did they send the symmetric key to the server? Being
They use the same data on the client and on the server to generate the same key pair, the same keys.
okay, this seems pretty
That's
bad.
why never write your own crypto, or if you do it the proper way.
I understand. Okay, thanks.
That's the ball for you. Please give it to him. If you want one, ask a question.
Thank you.
I have blue balls.
Okay, sir, if you say so.
Who wants one?
Next question. Yeah, okay.
You want one?
Yeah, I saw in the Python implementation that you hard-coded the key and the IV. So I guess you can take it even further, right, and develop it. So
Yeah,
you'll-
further in-
because this way it only works in this situation.
Yeah, the thing is, this is a very specific case. What the message I want to transmit here is that when you're stuck, get unstuck for yourself. I'm not a programmer. I'm a shitty programmer if I'm a programmer. And I couldn't find a solution on Google, so I decided to build my own. The thing is, this was the first time when I encountered this encryption, not the problem with the key on the client side. And yeah, further development, yeah, it would be cute to add the input field for the IV and the key to do it on the fly, but you can always change the Python code and change the IV and the key. Here you go. Okay, we have a question there. It's not an exploit, actually. The thing is, I was on a pen test, and I couldn't test the application because the developers, yay, they encrypted the payload, the parameter, the data. If you can see after the, yeah, you cannot see. After decrypting it, I could alter and add parameters of my own. I could test the way I'm used to test. Yeah, the practical approach was that I could do my job, and the customer could get something out of paying me to do my job. I have more balls. Blue also. Come on, don't be shy.
Okay.
Okay, we have one there.
Thank you for your very interesting presentation. The only thing what I didn't get, how could you restore the key?
The key,
How you generated the same one?
I got the method from the client, which I disassembled, and I used the same method they use, and I could create my own key. The IV was hard-coded, and the key generation was based on an insecure method, and I got the same key.
So that one was pseudo key, yes, as I understand. So the pseudo randomness you mean was weak, yes?
Extremely weak. It was based on the current date. Actually.
Okay, I see. Thank you.
I don't want to give out too much details, but yeah, the date was the...
Nice shot. Okay, any other questions?
So we have one question here.
Hi, thank you for the presentation. Have you tried the Pro version because it will save you time and money in the future?
The Pro version of Burp? Yeah. I was using the Pro version of Burp, actually, but it didn't give out much help in this situation. Yeah, I recommend to everyone use the Pro version. It's quite cheap and it's the best tool out there for pen testers. Sorry. I think I have two more. So we have a question here, and the last one.
Hi, Cosmin.
Hi.
I think it's a fair question to ask if you would have used Java instead of Python, you could have gotten this result earlier, right?
If I had gone with Java for my implementation, it would have been so much easier.
Thanks.
Mainly. But remember, I hate Java. Okay, we have the last question there. Why do I hate Java? Okay, the honest answer is because I don't know it really well, and typecasting sucks. Okay, everyone, thank you, and have a nice day at DefCamp, and maybe see you next year. Yeah, I have another slide here. Thanks.